online stock span. So for this problem, we are going to design an algorithm that collects daily prices of goods for some stock and returns the span of that stock's price for the current day. So what is the meaning of the problem? Let's just see some examples. Yeah. So for this example, we have such kind of array like 7212, and the price of the stock today is 2. Yeah, so today is 2, and we have such kind of array, and we just need to check how many numbers before this number 2, which is less than or equal to 2. So 2 is less than or equal to 2, 1 is less than or equal to 2, and this 2 is less than or equal to 2. How many numbers? It's going to be 3. And also we need to include the current number, which is going to be 4. So this is why the result is going to be 4. And let's just check another example, like 7, 34, 1, 2, and the price is 8. So how many numbers? 1, 2, and 8. So it's going to be 3. Yeah, so this is the idea. So the basic idea is that we are going to, so for example, if we are giving such kind of array, so for example, inside of the first example, 180, 60, 70, 60, 75, 75, and 85. Yeah. If we are giving such kind of array, so for each of the number, we just need to check how many numbers which is going to be smaller than the current number and which is going to be the previous numbers before this number. Yeah, so this means we're going to check from the left side how many numbers which is going to be less than or equal to 100. So it's going to be 0, but we're going to include this 100, so it's going to be 1. And then we're going to check 80. How many numbers from the left to the right which is going to be less than or equal to 80. So while we find this 100, we're going to stop it. Yeah, so the answer is going to still be 1. And for this 60, and it's going to still be 1. And for 70, so this 60 is one number, which is less than or equal to 70. And including 70, it's going to be 2. Yeah. And for the next one, this is 60. And how many of them? It's going to be 1. And 75, how many of them? 1, 2, 3, and 4, including the self. So it's going to be 4. And what about 85? So 1, 2, 3, 4, 5, 6. So this is why we're going to return a 6. Yeah. But the problem is that we don't have such kind of array. We only have a next method. It is inside the class stock spanner. So this means for each time running of the next method, we're going to get a price. So for example, the first running of the next is 100. So the second running is going to be 80 for the price. Yeah. And also, let's just check that. There are going to be at most 10 to the power of 4 calls. Yeah, for this next method. Yeah. So this means that definitely we cannot solve the problem by using the brute force. So by using the brute force, we can put all the numbers inside an array, and then we're going to check from the right to the left, so it's going to be n squared. So here n squared means the number of calls times the number of calls. Yeah. So for each of the call, it's going to be 10 to the power of 4 times complexity. It's going to be O(n). But currently, we need to solve it in O1 time. I mean, for each of the call, it's going to be O1 time. So in total, it's going to be O(n) time, 10 to the power of 4. Yeah. So if we are going to check the previous numbers, which is less than the current number. So for example, the current number is 80, and this previous number is 100. Yeah, we are going to check how many previous numbers which is less than or equal to 80. So this is going to be a stack problem. It is similar to next greater numbers, but currently we are going to check how many numbers which is less than or equal to the current number. Yeah. So this is going to be a typical stack problem. Definitely, if we first of all, we need to think about this problem as a stack problem, and then we're going to think of it as a monotonic stack problem. Yeah, because we are going to check all the numbers which is going to be less than or equal to 80. If this is 100, we're going to stop check. But this 100 is going to be a memory. It's going to be a boundary point for us to check. So let me just explain why we can use such kind of method to solve the problem. Yeah. So if we have such kind of numbers, so currently there's nothing inside of the stack. So let me just use a infinity as the first number. This is for checking the stack. This means if we put a infinity inside of the stack, we don't need to check if the stack is empty, because definitely there's something inside of the stack. It's going to be this number, infinity. And then we're going to check the next number, 100. So we're going to put this 100 inside of the stack. Yeah, but before that, we need to check the previous numbers inside of the stack, if that is less than or equal to 100. So definitely this infinity is more than 100. So this means we can put it directly inside of the stack. Yeah, and we need to return a value of 1. So this means for this 100, we're going to set a current index, which is going to be 0. For this 100, we're going to have an index 0. But for this infinity, we're going to set an index as -1. So in this way, we can calculate directly for the result. It's going to be 0 minus -1, which is going to be 1 for our answer. Next, we're going to check the next number, 80. Yeah, because the 80 is less than 100. So this means we can directly put it inside of the stack. And currently we're going to have an index which is going to be 1. Yeah, but the final result is going to be 1 minus 0. Yeah, because this is going to be the boundary. Yeah, so 1 minus 0 is going to be 1. And next, we're going to put the next number similarly. We're going to put 60 inside of the stack, because 60 is less than 80. So the index is going to be 2. The result is going to be 2 minus 1, which is going to be 1. And next, we're going to check 70. Yeah, but we cannot put 70 directly inside of the stack, because this is a monotonic decreasing stack. Yeah, because 70 is more than 60. So this means we need to pop 60 out of the stack. Yeah, and then we're going to put 70 inside of the stack. So the index for the 70 is going to be 3. And the final answer going to be the current index, which is going to be 3 minus 1. Yeah, because this one we've already popped it out. We've already popped out. We only need to consider this 80. It is the boundary, and this is the memory value. Actually, yeah, we put this value as our memory value. This is why we're going to solve it in 01 time, because this is still inside of the stack. And we're going to use the 3 minus 1, which is going to be 2, which is going to be the answer. Next, and we're going to check 60. Because 60 is less than 70, we're going to directly put it inside the stack, and we're going to have an index which is 4. And we can check the final result, which is going to be 4 minus 3, going to be 1. And then we're going to check 75. And because 75 is more than 60, and 75 is more than 70, this means we can put this one out of the stack, and we can pop this one out of the stack. And this index is going to be 5, and 5 minus 1, because this 80 is still inside of the stack, because this is a monotonic decreasing stack. We can use 5 minus 1, which is going to be 4, which is going to be the answer. So for the final value, which is going to be 85. So for this 85, because this 85 is more than 75, we're going to pop it out of the stack, because all those values has already popped out, but this 80 we can still pop it out. Yeah, so what's left behind is 100, because 100 is more than 85. Yeah. So the index of 85 is 6. So this means we can use 6 minus 0, which is going to be 6. Yeah. So it's going to be here, which is 6. Yeah. So this is exactly how we're going to solve the problem. So while preparing the stack, we're going to prepare two values, the price and the index, because we need to use those two values. This is going to be easier for the coding. Yeah. If we put those two values inside the stack, this means we don't need to check if the stack is empty, because this is a boundary, because there's going to always be at least one value inside the stack. Yeah. And similarly, we need to keep the current index, and we need another variable which is going to be the current index, because we're going to use it, and we're going to put the current index and price together inside of the stack. Yeah. Now let's try to solve the problem. So the problem is a little bit harder, because we are not giving an array. For each time of running the next, we are giving a value. So this is the hard part of the problem. So we have to get familiar with how to code using such kind of a method. So this is similar to online method, because for each of the running of the next, we are having a price. Yeah. So normally we are not giving an array. we are giving one value of price at each of the time, and we are going to return so how many numbers, which is before the price and which is less than or equal to this price. So as we said before, we're gonna define a stack. So inside the stack, it's gonna be a tuple. So the first value gonna be the index. We're gonna set it -1, and the price we're gonna set it as infinity. And similarly, we're gonna set a current index. So we're gonna set it as -1. So before coding, while coding the next, we're gonna update the current index. Because for the current number, so the current index is gonna become 0. So -1 plus 1 is gonna be 0. And then we're gonna check the stack. Because the stack is not empty, so we don't need to check that. We just need to check the price. So this is the template of monotonic stack. So monotonic decreasing stack. So if the price is more than and equal to the previous ones, so which is stored inside of the stack. So we're gonna use the self.stack with -1 and with 1, because -1 is the last value on top of the stack, and this one is for the price. So if this value, first of all, if this 100 is more than and equal to the infinity, but currently it is not, so this means we don't need to do anything. But if it is more than that, we're gonna pop it out. So self.stack.pop, we can directly pop it out. So otherwise, we need to put it inside. So self.stack, we're gonna append the value. So the value gonna be the index and price. So the index is gonna be the self.current index, and price is gonna be the current price. So now we need to get our final return. So the final return is just a mathematical calculation. It's gonna be self.current index minus the self.stack. Here gonna be a -2 with 0. So let me explain. Because here for designing of the stack, we've already put a value inside the stack. So this is why here we're gonna use a -2. Because for example, this is 85. Actually, we've already put this 85 inside the stack. But at the same time, we've already popped out all those values, which is smaller and equal to 85. So what's going to be the current index? It's going to be this index. So 0, 1, 2, 3, 4, 5, 6. So it's going to be 6. And what is this value? This value is for this 100. This is why it is a stack -2. So this is a stack -1, and this is a stack -2. So it's going to be 0. So 6 minus 0 is going to be 6, which is for the last value. So this is why we're going to use the stack -2, because -1 is the current value, the current index. Definitely we don't need it. It is not necessary. It has to be -2. It has to be the value before the current value, which is going to be -2. I think this is the only difficult part. It's going to be a little bit of mathematical calculation if we design it like this, with -1 for the first index. Actually, this is just a dummy index and a dummy value for the price. Now let me just run it to check if it works. As you can see, it works, and now let me just submit it. As you can see, it works, and it's pretty fast. And the time complexity is just O(n). N is for the number of coding times, which is 10 to the power of 4. Actually, for each running of the next method, which is only O(1) time. This is why we prefer to use the monotonic stack, and maybe only the monotonic stack can solve the problem. I think that's all about it. Thanks for watching. See you next time.